Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last sessions, we have completed the units and measurements chapter. So I have taken 4 lectures. So in that 4 lectures, the complete dimensional analysis, error analysis, and the devices like vernier caliper, screw gauge. So how to find the reading and how to correct the reading. So everything we discussed. So what you have to do is just write the summary of that chapter and do the practice sheet. Okay, chalo. So next in today's session we are going to start the next chapter, that is basic maths. So where in basic maths we'll cover whatever the mathematical tools that are required to solve the physics numericals. See, if you consider any chapter in physics, so that chapter compulsory involves basic maths, and one more thing, it's vectors. Okay, so these two are the fundamental things every student should learn. Okay, so the basic maths, especially the differentiation part, integration part, so this is very important. And then coming to the vectors, so that also we'll discuss in detail, where in vectors we'll cover 2 lectures. So in 2 lectures I'll complete the complete vectors. Okay, so whatever that is required for the physics, the basic maths, so that I'll cover. So I'm not going for complete mathematics part here. So just I'll cover whatever that is required for the physics. Okay, and we'll do some questions as well, right? So we are not going to get any direct questions based on this, but this is important to solve the numericals in physics. Chalo. So with this, let's start the basic maths lecture number 1 in today's session. So as usual, so just be calm guys. So avoid the disturbances around you. So just stay with me for the next 1 hour or 1.5 hours. So my throat is not good today, so I'll just wind up bit early. I may wind up bit early, so if I feel uncomfortable. So but I'll cover in 2 to 3 lectures the complete basic maths. Chalo. So today's targets we have. So first let's go for the basic trigonometry, then we'll be having the differentiation concept. Okay, so first basic trigonometry, you guys are all aware of the basic trigonometry in the previous class 10th itself, right? So where you learnt about the different trigonometric ratios, so that is sine theta, cos theta, tan theta. So do you want me to write that? So let me write quickly. So just let me write it here. So in the basic trigonometry, we have, so sine formula, cos formula, everyone knows, right? So let's suppose this is the right angle triangle, right angle at here. So this angle is theta, let's suppose. So this is said to be opposite, this is adjacent, and then this is hypotenuse, right? So then, so now in this I can write, so the sine theta, which is opposite by hypotenuse, the formula, and cos theta, which is adjacent by hypotenuse, and then tan theta, which is opposite by adjacent. So these are the basic 3 trigonometric ratios, and 3 more are the reciprocals of the first 3. So cosecant is a reciprocal of sine, which is hypotenuse by opposite, and then so secant is a reciprocal of cos, so which is hypotenuse by adjacent, and then so cot is a reciprocal of tan, so which is adjacent by opposite, right? So from here I can write, so the sine theta is a reciprocal of cosecant theta, so which is 1 by cosecant theta we can write. So similarly cos theta is equals to 1 by secant theta, and then tan theta is equals to 1 by cot theta. Clear? So this is the basic thing. Okay, so this you already learned in the grade 10th itself. So now, so we have seen the specific angles of the trigonometry in the class 10th. So where 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So these are said to be the specific angles of trigonometry. So where 0, 30, 45, 60, 90. So you know the values, right? So sine 0, 0, Sine 30, 1 by 2. So this is 1 by root 2, root 3 by 2 and 1. So the simple way to remember this is, so let me write this way. So 0 degrees, 30 degrees, 45 degrees, 60 degrees and then 90 degrees. So these are the specific angles of trigonometry. So then write sine, cos, tan here. So just remember the first one. Remember the first row. So sine 0, 0. This is sine 30, 1 by 2. Sine 45, 1 by root 2. Sine 60, root 3 by 2. And sine 90, it's going to be 1. So this is the first sign. So then cos, just reverse these values. So here 1, just write the reverse order. So root 3 by 2, 1 by root 2, 1 by 2 and then 0. So and then sine by cos is a tan, right? So which is 0 by 1, 0. So 1 by 2 by root 3 by 2. So which is 1 by root 3. So 1 by root 2 by 1 by root 2, 1. Root 3 by 2 by 1 by 2. So which is root 3. So 1 by 0. So infinity, undefined. Clear? So if you know sine, cos, tan, then you can write cosecant, secant, cot, simple way, right? So this is how you can remember the specific angles of trigonometry. So this also you already know in grade 10th level itself. So now how do you convert the angle from radians to degrees, degrees to radians? So for example, so if I take the arc property, so let's suppose this is the length of the arc L and then this is theta. So then this angle is R, let's suppose. So then we know that L is theta is equals to L by R. The theta is equals to L by R. Okay. So now how do you write the degrees in terms of radians? See, if I take the circle, so to complete one complete rotation, so how much distance it covers? L is the distance, right? Arc distance. So if I have to calculate this total angle for 360 degrees, how much it is in radians I have to calculate. So this theta is in the radians. Okay. So simple basic maths. We are not doing any complex things here. So theta is equals to, so what is this total length for the complete circle? So the 2 pi r, the circumference, right? So by r. So r cancel. So theta is equals to 2 pi radians. So what is theta here? So this is for one complete rotation, it's going to be 360 degrees, right? So that means 2 pi is equals to 2 pi radians is equals to, shall we say, so 360 degrees 2 pi radians is equals to 360 degrees. From here, so we can write pi radians is equals to 180 degrees. So this part you should remember. Done. How do we convert? So the radians to degrees and degrees to radians. So pi radians is equals to 180. Remember this. So based on that, you can write the remaining. 2 pi radians is 360. So pi is 180. 90 means pi by 2. So 60 is pi by 3. 45 is pi by 4. So 30 is pi by 6. Very simple thing, right? Sure. Next. So now, so we know some important trigonometric identities, right? So the trigonometric formulae, so which includes the identities. So there are three major identities. So one is sine square theta plus cos square theta is equals to 1. So then secant square theta minus tan square theta is equals to 1. So here it is a printing mistake, I guess. So this is 1 and then, oh. So write like this. So secant square theta minus tan square theta is equals to 1. And then we can write 1 plus tan square theta is equals to secant square theta. And cosecant square theta minus cot square theta is also equals to 1. So these are the three major trigonometric identities. So then we have double angle formulas. So where sine 2 theta is equals to 2 sine theta cos theta. This is new to you guys. So write these formulas. So sine 2 theta, write along with me. Sine 2 theta is equals to 2 sine theta cos theta. Okay, remember this formula. And then cos 2 theta, it's cos square theta minus sine square theta. So cos 2 theta is cos square theta minus sine square theta. So this you can also write it in this way. So in place of cos square, so can we write 1 minus sine square theta in place of cos square? So we can write 1 minus sine square theta minus sine square theta. From here I wrote. Okay, na sine square theta plus cos square theta is equals to 1. From there, cos square theta is equals to 1 minus sine square theta. So here, so 1 minus sine square theta minus sine square theta, which is 2 sine square theta. This is a cos 2 theta formula, one more formula. So or else you can write it in complete sine as well. So cos 2 theta is equals to, complete cos itself. So cos square theta minus, so in place of sin square theta, so shall we write 1 minus cos square theta? 1 minus cos square theta in place of sin square theta. So this is cos square theta minus 1 minus of minus plus cos square theta. So which is nothing but 2 cos square theta minus 1. So this is also the cos 2 theta formula. So that means cos 2 theta you can write in terms of cos and sin, in terms of completely sin, and in terms of completely cos. Clear this part, everyone? And then, so we have tan 2 theta is 2 tan theta by 1 minus tan square theta. So the tan 2 theta, write along with me. So 2 tan theta by 1 minus tan square theta. 1 minus tan square theta. So this is a formula. Clear? Understood, guys? Everyone? Chal, next. So then we have addition and subtraction formulas of trigonometry. So which includes, so the sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b. So tan of a plus b, tan of a minus b. So the simple way to remember is for sine, so a plus b is there, if it is plus is there, so just put plus here between those two. So then minus is there, so keep minus. So when sine term is there, so write one sine, one cos term together. So that means sine of a plus b is equals to sine a cos b plus cos a sin b. One sine term, one cos term, like that. Okay, and keep the same symbol in between. So for sine of a minus b, so now keep minus in between. So then write one sine term, one cos term. Sine a cos b minus cos a sin b. So this is the thing, right? So and similarly, if it is for cos, so what you do is just reverse the sign here. So if it is plus is here, so keep minus there. Okay, so then cos of a plus b, so which means write two cos terms and two sin terms. So cos a cos b minus sin a sin b, like that. So then cos of a minus b, so reverse the sign. So here minus is there, so plus, keep plus here. So then two cos terms, two sin terms, cos a cos b plus sin a sin b. Understood? Chalo. So then tan of a plus b, so which is tan a plus tan b by 1 minus tan a tan b. So tan of a minus b, which is tan a minus tan b by 1 plus tan a tan b. So these formulas everyone should remember. Already hope you guys already learned in the physics, maths as well. So Kundan sir's basic maths class already you guys have watched, I guess. So the same things will be there in the physics also. Okay, clear this part? Chalo, next. So let's do some questions. So let's find what is the sine 15 degrees. See, in specific angles till now we know that 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. So but 15 degrees how to find, we don't know. So just follow this procedure. So sine 15 degrees, so let me write this in terms of two known angles. In terms of two known angles. So what are the two known angles we can write? So 45 degrees minus 30 degrees, shall I write? Sine 15 degrees is equals to sine of 45 degrees minus 30 degrees. So which is in the form of sine of a minus b formula. Which is in the form of sine of a minus b formula. So just keep minus here. So then put sine a cos b and then cos a sin b. Cos a sin b. So then just substitute the values. Sine a, sine 45 degrees. Sorry guys. Sine 45 into cos 30 minus cos 45 into sin 30. Alright. So then, so here 1 by root 2. So the cos 30 value root 3 by 2 minus cos 45 1 by root 2. So into sin 30 1 by 2. So which is nothing but, so root 3 by 2 root 2. So my 2 here 2 root 2. So 1. So which is nothing but root 3 minus 1 by 2 root 2. So this is a sine 15 degrees value. So simply we can write sine of a minus b formula we can apply. So where sine a cos b, right? So sine a cos b minus cos a sin b. So sine 45 cos 30 minus cos 45 sin 30. So sine 45 is 1 by root 2. So where cos 30 is root 3 by 2. So just now we have seen. So cos 30 is root 3 by 2. So see here, cos 30 degrees root 3 by 2. Clear? Understood, guys? So similarly, so can we do the next question? Let's find sine 75 degrees. So the same procedure you can follow. For the second one, follow the same procedure, sine 75 degrees. So sine 75, I can write it as sine of 30 degrees plus 45 degrees. Sine of 30 degrees plus 45 degrees. So again, the simple way. So sine of a plus b formula. So just write the formula first. So keep plus in between when plus is there. So then write one sine term, one cos term. Sine a cos b and then cos a sine b. Cos a sine b. Right? So then, so just substitute the values now. Sine a, let it be a, let it be b. So sine 30 into cos 45 plus cos 30 into sine 45. So then this is going to be 1 by 2, so and 1 by root 2 plus, so this is root 3 by 2 into 1 by root 2. So then this comes out to be 2 root 2 here 1 plus 3 root 3 by 2 root 2. So we can write this as root 3 plus 1 by 2 root 2 is sine 75 degrees. So sine 15 is root 3 minus 1 by 2 root 2. So here I can write. So sine 15 degrees is root 3 minus 1 by 2 root 2. Whereas sine 75 is root 3 plus 1 by 2 root 2. Understood, guys? Clear? Chalo. So let's move further. So now the quadrants and their sign conventions. So this part is important. Just understand carefully. So here, let me take the 4 quadrants. So these are the 4 quadrants that we can take. So this is quadrant 1, quadrant 2, so quadrant 3, quadrant 4. So this is 0 degrees, 90 degrees, so 180 degrees, 270 degrees, and then again 360 degrees here. So that means one complete rotation. So the angles which are between 0 and 90, they lies between the first quadrant. So the angles which are there lies between 0 to 90. So they are in the first quadrant. So quadrant 1. So where 90 to 180. So the angles between 90 to 180. So they lie in the quadrant 2. Okay. And in the quadrant 3, 180 to 270. 180 degrees to 270 degrees. So they lie in the quadrant 3. So whereas in quadrant 4, so 270 to 360 degrees. So they lie in the quadrant 4. Right. So now see here. So the sign conventions. So to understand the sign convention, just remember this small trick. So all silver tea cups. All silver tea cups. So here all means here all the trigonometric ratios are positive. So sine, cos, tan, cosecant, secant, cot, everything is positive. So here all the trigonometric ratios are positive. So you'll understand once I write the values. So just see here. So then silver, so the first letter sine. So where sine and its reciprocal cosecant. So these two are positive, remaining all are negative. Okay. And then here T, sorry, T stands for tan. So tan and its reciprocal cot. So these two are positive, remaining negative. So quadrant 4 cups. So cos. So cos and its reciprocal secant. So these two are positive, remaining are negative. Okay. So this part you should remember. Now, so here, so what are the angles that lies in the first quadrant? As I said earlier, so less than 90. So that means 90 minus theta. These values will lie in the first quadrant, where 90 to 180 they lie in the second quadrant. So which means, so 90 plus theta and 180 minus theta. So they lie in the second quadrant. So more than 90 and less than 180. So then in the third quadrant, so more than 180, less than 270. So which is nothing but 180 minus theta and 270 plus theta. So they lie in the third quadrant. And in the fourth quadrant, so 270 plus theta and then 360 minus theta. So and more than 360, so they lie in the first quadrant or second quadrant. So again it depends. right? Chalo. So now see here, this is a quadrant part. So now how do we write the values? Let's suppose if you have to find the sine 90 minus theta. So let me write in the next slide. So 90 minus theta, so what will be its value? So first 90 minus theta, it lies in the quadrant 1. 90 minus theta, it lies in the quadrant 1. Understand carefully. So in the quadrant 1, all the trigonometric ratios are positive. All the trigonometric ratios are positive. So then here one more important note. Whenever 90 and 270, for 90 degrees and for 270 degrees, so the sine converts to cos and cos converts to sine. So and then tan converts to cot, cot converts to tan, and then cosecant converts to secant, and secant converts to cot, cosecant. Okay na? So this you should remember for 90 and 270 degrees. So if I write the values, then you'll understand better. So just remember this one. So now let me write it here. So what is sine of 90 minus theta? What is sine of 90 minus theta? So first thing is 90 minus theta lies in the first quadrant, right? So in the first quadrant all are positive, okay? And then so 90, so if 90 is there, so sine will convert to what? Cos, and then write theta, that's it, okay? So then so cos of 90 minus theta, so you just write this down, guys. See, so first quadrant all are positive. So 90 minus theta is in the first quadrant, all are positive. So plus, so when 90 is there, cos converts to sine, right? So then, so the next tan of 90 minus theta, so which is equals to, so tan converts to cot theta. So as it is 90 minus theta, all are positive. So then what is cosecant of 90 minus theta? So which is plus secant theta. And then so what is secant of 90 minus theta? Plus cosecant theta. And then so what is cot of 90 minus theta? Plus tan theta. Understood, guys? So clear this part. So similarly, let's write for the this one 90 plus theta. So first 90 plus theta lies in which quadrant? The second quadrant. So this lies in the quadrant 2. This lies in quadrant 2. So in quadrant 2, so which are positive? So silver means sine and cosecant. These two are positive, remaining all are negative, right? So now, so you can write what is sine of 90 plus theta. So sine of 90 plus theta, and then cos of 90 plus theta, tan of 90 plus theta, and then cosecant of 90 plus theta, secant of 90 plus theta, and then cot of 90 plus theta. So now write this down. So in the second quadrant, so only sine and cosecant are positive. So this is positive and this is going to be positive. So remaining all are negative. So negative, 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 negative. Just keep it like this. So now when 90 is there, so sine converts to cos, cos theta. Then so cos converts to sine theta. So then tan converts to cot theta. So sine convention you'll get from here. So which quadrant it lies? So if 90 is there, so the sine converts to cos and cos converts to sine. Tan converts to cot, cot converts to tan. And then cosecant converts to secant, secant converts to cosecant. So here cosecant means secant theta. So then secant which is cosecant theta. And then cot which is tan theta. Clear? Understood, guys? So let me write for the next quadrant as well. So for 180 minus theta. So 180 minus theta lies in which quadrant? Again quadrant 2. So 90 plus theta, 180 minus theta, they lies in the quadrant 2. So in the quadrant 2 which are positive? So sine and cosecant. Sine and cosecant are positive. So where? So the sine of 180 minus theta, and then cos of 180 minus theta, tan of 180 minus theta, and then cosecant of 180 minus theta, So then secant of 180 minus theta. So then cot of 180 minus theta. So here, so in the second quadrant, 180 minus theta lies in the second quadrant. So sine and cosecant are positive. So this one and this one are positive, remaining all are negative. So negative, 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 negative. So keep it like that. So only for 90 and 270, only for 90 and 270, so the sine converts to cos, this happens. So but for 180 degrees and for 360, so the sine remains as sine, cos remains as cos, tan remains as tan. So there will be no change. So that's why here you can write, so the sine, so here 180 is there, so sine will be sine itself, sine, so theta, and then cos will remain as cos. So just you have to take care of the sine convention, that's it. So then tan remains as tan, cosecant remains as cosecant, secant remains as secant, so cot remains as cot, that's it. Understood? So now let's go for the 180 plus theta. So 180 plus theta lies in which quadrant? So it lies in the quadrant 3, right? 180 plus theta. So in quadrant 3, which are positive? So tan and cot are positive, all silver T cups. So third quadrant T, tan and cot. So then write the same thing again, sine of 180 plus theta, then cos of 180 plus theta, then tan of 180 plus theta, and then cosecant of 180 plus theta, then secant of 180 plus theta, then cot of 180 plus theta. So then we can write, see here, so in the third quadrant tan and cot are positive, remaining all are negative, that's it, remaining all are negative, right? So sine 180, for 180 sine remains as sine, so minus sine theta. So this is minus cos theta, this is plus tan theta, so this is minus cosecant theta, and then this one, so minus secant theta, so this is plus cot theta, that's it. Understood guys? Clear? Sure. So let's move further. So for 360 minus theta and 360 plus theta, so first of all 360 minus theta lies in which quadrant? 360 plus theta, so which lies in the quadrant 4, 0 to 270 and this one, so which is nothing but quadrant 4, 360 minus theta. So here you can do the homework. For 270 is missing, so let's do one thing. So after this one, 180 plus theta, 180 minus theta, 180 plus theta, so then do for the 270 minus theta and then 270 plus theta. So for 270 minus theta, which lies in it lies in which quadrant? So 270 minus theta, which lies in the third quadrant, quadrant 3, right? In quadrant 3 tan and cot are positive. So now let's write the values of sine of 270 minus theta, and then cos of 270 minus theta, and then tan of 270 minus theta, and then cosecant of 270 minus theta, and then secant of 270 minus theta, and then so cot of 270 minus theta. Clear? So now, so first in the third quadrant which are positive, so I can write tan and cot are positive, so tan positive, cot positive, so remaining all are negative. This part is clear? Chal. So now for sine 270 is there, 270 means sine converts to cos, so minus cos theta, so here it is minus sine theta. So and here tan converts to cot theta, so tan of 270 minus theta is plus cot theta, and then cosecant converts to secant, so minus secant theta, secant converts to cosecant, so minus cosecant theta, cot converts to tan, so plus tan theta. Clear? Sure. So next let's write the 270 plus theta. So 270 plus theta lies in the quadrant 4. So in quadrant 4, so the cos and secant are positive, cos and secant are positive. So now let's write. So what is sine of 270 plus theta? And then what is cos of 270 plus theta? So then tan of 270 plus theta. So then cosecant of 270 plus theta. So then secant of 270 plus theta. So then cot of 270 plus theta. So now let's write the values. So in the quadrant 4, cos and secant are positive. Cos is positive, secant is positive. So remaining all are negative. Right? So and when 270 is there, sine will be converted to cos. So minus cos theta. So cos will be converted to sine plus sine theta. So tan will be converted to cot. So cosecant will be converted to secant. And then so secant will be converted to cosecant. And then cot converts to tan. Clear this part? And then we have the last quadrant, the last pair, which is 360 minus theta and 360 plus theta. So 360 minus theta again lies in the quadrant 4. In the quadrant 4, cos and secant are positive. Right, remaining all are negative. So then I can write sine of 360 minus theta. So cos of 360 minus theta, tan of 360 minus theta, and then cosecant of 360 minus theta, and then secant of 360 minus theta, and then cot of 360 minus theta. So from here we can write, see here, so fourth quadrant, cos is positive, secant is positive. So remaining all are negative like this. So then next, so let's write. So sine, when 360 is there, sine remains as sine. So this is sine theta. So this is cos theta. So this is tan theta, cosecant theta, secant theta, and then cot theta. Understanding? So now you got the idea, right? So 360 plus theta, it again lies in the first quadrant, more than 360. So again the quadrant 1, right? So quadrant 1, again all are positive. So that's why sine of 360 plus theta, so which is plus sine theta, all are positive. So cos of 360 plus theta plus cos theta. For 360, sine remains as sine, right? So this is plus cos theta. And then tan of 360 plus theta, which is plus tan theta. And then cosecant of 360 plus theta, which is plus cosecant theta. And then so secant of 360 plus theta, which is plus secant theta. And then so cot of 360 plus theta, which is plus cot theta. Understood, guys, this part? Clear? So let's move further. So let's do few questions. So find the value of sine 120. So previously we did it by sine of a plus b cos of a plus b. That's a lengthy procedure. So now the simple way, you can use the quadrants and sign convention. So sine 120, shall I write this as sine of 90 plus 30? So it is in the form of sine of 90 plus theta. Sine of 90 plus theta, right? So what is sine of 90 plus theta? What is sine of 90 plus theta? First, 90 plus theta lies in the second quadrant. In the second quadrant, sine and cosecant are positive, right? So that's why sine is going to be positive. So 90 plus theta, if 90 is there, sine converts to cos. So that's why cos theta. So this thing, right? So then sine 120 will be equals to, so in place of sine, so cos, shall I write, in place of theta what do we have? 30. So cos 30. So therefore sine 120 is equals to, actually this is equals to cos 30 degrees. So what is cos 30? So cos 30 is root 3 by 2. So therefore sine 120 degrees is equals to root 3 by 2. Understood? Simple way, 90 plus theta. So which is plus cos theta. So in the similar manner, can you solve the second part? So cos 210 degrees. So how can we do this? So first cos of 210, we can write it as cos of 180 plus 30 degrees. 180 plus 30 degrees. So it's in the form of cos of 180 plus theta. Cos of 180 plus theta. So 180 plus theta lies in the third quadrant, right? So 90 minus theta first quadrant, 90 plus theta and 180 minus theta second quadrant. So and then 180 plus theta, 270 minus theta in the third quadrant. So in the third quadrant, so we know that tan and cot are positive. So cos is negative minus. So when 180 is there, cos remains as cos. So cos minus cos theta. So therefore, which we can write it as, so minus cos 30 degrees. Cos of 180 plus theta is minus cos theta, which is minus cos. In place of theta we have 30. So just write 30. So then minus, this is root 3 by 2. Clear? Understood? Sure. So let's move further. So let's find the value of sine 315 degrees. So how do we write this one? Sine 315 degrees. So which we can write it as sine of, so 270 plus 45 degrees. Sine of 270 plus 45 degrees. So which is in the form of sine of 270 plus theta. So 270 plus theta lies in the quadrant 4. Yes or no? More than 270 means lies in the quadrant 4. So in the quadrant 4 only cos and secant are positive. So sine is negative. And then 270 is there, sine converts to cos. So minus cos theta. So here sine, this converts to minus cos. So in place of theta what do we have? 45 degrees. So therefore minus cos 45 is 1 by root 2. That's it. Understood guys? Clear? So let's suppose if I ask you to find the value of, so the question, so find tan 150 degrees. So how do we solve this tan 150 degrees? So tan 150 we can write it as tan of 90 plus 60. Tan of 90 plus 60 degrees. So it's in the form of tan of 90 plus theta. So 90 plus theta lies in the second quadrant. In the second quadrant, only sine and cosecant are positive. So tan negative. And when 90 is there, tan converts to cot. So this is minus cot theta. So that's why it becomes, so tan of 90 plus 60 is nothing but minus cot 60 degrees. Minus cot 60 degrees. So here what is cos 60, cot 60 value? So tan 60 is root 3. So cot 60 is minus 1 by root 3. Clear? Understood this part? Everyone? Chal. So next. So the important note. So trigonometric function of an angle 2n pi plus theta, where n is equals to 1, 2, 3, 4 will remain same. So as we discussed earlier, so sine of 360 plus theta, 2 pi means 360, right? 360 plus theta. So 360 plus theta, 360 plus theta. So it remains same. So in place of this 2 pi, so it can be 4 pi or it can be 6 pi or it can be 10 pi, it can be 100 pi. So the even multiples of this one, if it is in the form of 2n pi, so where n is equals to 1, 2, 3, 4, so the trigonometric ratio will not change. It remains as it is, like we have seen. So sine 360 plus theta, which is 360 sine theta only. Yes or no? So like that. So the same way. So if it is sine of 720 plus theta, so then also it's sine theta only. Understanding? Clear? Sure. Next. So now, so one more important thing, that is, if theta is very, very small, in most of the problems, so our derivations, especially in the second year ray optics and wave optics part, so we consider the theta to be very, very small. So if theta is the angle which is very, very small, then so we write it as its small angle, the small angle d theta, where d theta is nothing but very, 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 very minute value. Okay. So if theta is very small, the sin theta tends to theta, cos theta tends to 1, tan theta tends to theta. So remember this part. So the sin theta tends to theta. So cos theta tends to 1, whereas tan theta tends to theta. So we can also write when theta is small, so the sin theta tends to theta, which tends to tan theta. So that means sin theta cos theta will become equal if theta is very, very small. So this part you'll understand when we do the wave optics clearly. Okay, so if theta is small, so we can also write it as d theta. So where sin of d theta is d theta, cos of d theta is 1, tan of d theta is d theta itself. Understood, guys? Clear? So just remember this part. So now let's enter the differentiation part. So the differentiation is a mathematical tool, so which is very, very important to solve the questions or physics numericals. Okay, so in every chapter we get the application of the differentiation. Okay, so now, so what is differentiation? First of all, what is differentiation? So the differentiation mathematical meaning is nothing but it's a slope of a curve. It's a slope of a curve. Okay, so now, for example, so if I write the graph like this, so this is the graph. So if this angle is theta, right? So then you know that the slope m is equals to the formula tan theta, the tan theta. So this is y versus x. Okay now. So now the differentiation, so the differentiation we write it as, so the dy by dx, remember from now. So this is that I am not going into deep discussion because that's mathematics part. So in physics we just need its application. How do we solve the questions? Okay, so the tan theta, which is equals to differentiation of y with respect to x. This is the differentiation. So the dy by dx is nothing but, so we are differentiating the y term with respect to x. That's it. Clear? Chal. So let's move further. So the slope of a curve, as we discussed earlier. So here, if I take the curve like this, if I take the curve like this, so then if we need the slope at this point, so let's suppose this, what we do, we just draw the tangent there. So let's suppose this tangent is making the angle theta 1 here. So then let this point be P. So the slope at P, which is equals to m is equals to tan theta 1, right? If you need at some other point, so just draw the tangent at this place. So let's suppose it's making theta 2 with respect to the positive x-axis. So let's name this point as Q. So then slope at Q, which is nothing but m1, this is m2, so which is tan theta 2. Okay, so now if you need the change, in this is y versus x. So I guess I wrote it in the next slide. Yeah, so I wrote it here. I'll explain clearly. See here. So what is the average rate of change in y with respect to x? So what is, see, if a body is making some graph like this, y versus x graph is, let it be like this. Can I just understand the meaning? We'll go for the numericals there. That part is important. Okay na, for us. So here P point is there, here Q point is there. P has the coordinates x1, y1 and Q has the coordinates x2, y2. Okay, so now see here. So the change in y, the average rate of change, what is the change from here to here, from P to Q? So which we can write it as change in y by change in x. So what is change in y? So final minus initial, y2 minus y1. So and then change in x, final in x minus initial in x, x2 minus x1. So which is nothing but, so the change in y by change in x, which is nothing but the slope of the PQ, which is nothing but the slope of the PQ. Just draw the slope. So which is nothing but tan theta. So therefore y2 minus y1, we can write delta y by delta x. So then the tan theta is equals to delta y by delta x. So this is a, so total change in the y, average rate of change. So if it is very, very close, if these 2 points, if this P and Q points are very, very close, okay, if these P and Q points are very, very close, so then what we do? So the average rate of change will convert to instantaneous rate of change, very close. So then y2 minus y1, so the very small change in y, the small change in y, so which we write it as dy. From now onwards, whenever we say very, very small, so then remember differentiation term. So previously also I wrote here, as theta is very, very small, which we write it as d theta. So there is very small change in the y, very small change in the y, which is dy. So and very small change in the x, dx. So for very close things, the instantaneous, whenever we say instant, so then we should apply the differentiation. So this is a differentiation which is equals to slope. So differentiation is nothing but the slope of the curve. So dy by dx is equals to tan theta. Okay, na? So this is just the theory part. So what we actually need is this one. So the rules for differentiation, how do we apply it in the physics? That part is important. So the general formula for differentiation, so the d by dx of x to the power n is equals to n into x to the power n minus 1. So n into x to the power n minus 1. So this you should remember. So now let's do some examples so that you will understand better. So for example, if I say find the d by dx of x square, so then what we do? So just compare this one with this. So in place of n we have 2. So 2 into x to the power 2 minus 1, which is nothing but 2 into x to the power 1, which is 2x. So d by dx of x square is 2x. Okay. So next, if I have to calculate, so what is d by dx of some root x? So root x value, how do we calculate? So first I'll write this as d by dx of, in terms of root, in place of root x, I'm writing it as x to the power 1 by 2. I can write it as x to the power 1 by 2, right? So this is a basic things, that's why I'm going a bit faster. Okay guys, so then d by dx of x to the power 1 by 2, so which we can write it as, in place of n we have 1 by 2 now. So just substitute now, 1 by 2 into x to the power 1 minus 1 by 2. So x to the power 1 minus 1 by 2. So this is 1 by 2 into x to the power minus 1 by 2. 1 minus 1 by 2 is minus 1 by 2. So which we can write it as 1 by 2. So this I can write as x to the power 1 by 2, 1 by x to the power 1 by 2. So which is nothing but 1 by, so this is x to the power 1 by 2 is root x. Clear? So this minus 1 by 2, so if we send this to denominator, it becomes 1 by x to the power 1 by 2. So 1 by 2 root x. This is a differentiation of root x. Clear? So example 3, let me take the example 3. So the d by dx of, let's write, so 1 by x. So the d by dx of 1 by x. So which is nothing but, we can write it as x to the power minus 1. We can write it as x to the power minus 1, right? So if it is x to the power minus 1, in place of n we have minus 1, right? So minus 1 into x to the power minus 1 minus 1. In place of n we have minus 1 minus 1. So which is minus 1 into, so x to the power minus 2. So which is nothing but minus 1 by x square. So minus 1 by x square. Clear? Understood this part? And then along with this, you can also do the differentiation for the addition terms and subtraction terms. Okay. For example, if I take, so the differentiation of 2x square plus 3. So then how do we differentiate this one? So remember, so the differentiation of a constant is 0. The differentiation of a constant term is 0. Okay. So now here, how can we proceed with this? So first write the differentiation for the individual terms. So d by dx of 2x square and then d by dx of 3. D by dx of 3. So where differentiation of 3 is a constant, so that's why it 0, right? So then, so 2, just take it out of the differentiation, then d by dx of x square. So we just now have seen, so the differentiation of 2x square is 2x. So which is nothing but 2 into 2x, which is 4x. So this is the differentiation. Understood? And so one more thing, so the differentiation of log, so the log x base e, so its differentiation is 1 by x. Remember this one. Whereas the differentiation of the exponential, the d by dx of e to the power x, so which remains same, it will not change. D by dx of e to the power x is e to the power x only. Clear this part, everyone? Understood? Any doubts here? So then let me take one more question. So let's take the example. So the d by dx of, let's write some 2x square minus 3x plus 5. So do the differentiation of this. So how do we do that? Simply d by dx of first term 2x square, d by dx of second term which is 3x, and then d by dx of the third term which is 5. So 5 is a constant, its differentiation is going to be 0, right? So then, so what is d by dx of 2x square? So we can write it as 2 out. So and differentiation of x square is 2x minus, so 3 outside, and then we can write dx by dx. So dx by dx means 1. So this is 4x minus 3. This part is 1. So 4x minus 3. Clear? Understood the basic thing, guys? So what are the rules for differentiation? This part is important. So you just remember the basic things. That's it. Okay? Clear? Any doubts here? Chalo. So that's it, guys, from my end. So in the next session, again, I'll continue with the basic maths part itself, where we'll do the differentiation and integration, maxima, minima concept, and we'll wind up the basic maths in the next lecture itself. So my throat is not well, that's why I'm winding up a bit early today. So next session, I'll complete the complete basic maths. Okay, so till then, keep studying. All the very best, guys. Bye. Take care.